Okay, so this is similar to, or it's a version of number 8 off of the partial fractions homework, which is section 9.4. So this one's an example of it's a repeated linear factor, and this time it happens to be cubed. So anytime we have repeated linears or repeated quadratics, it just means we have to set up each iteration of what it could be. So for our first one, we'll have a over x plus 1, and then b over x plus 1 squared, because both of those would go into this, and then we know we have to have a c over x plus 1 cubed. And so if you look, this would be the LCD for all three of these things. I don't necessarily need that one or that one, but they're both possible, so I have to allow for the possibility. And then the next step is we multiply both sides by the LCD, so we get it to that equation that we end up working with. So I'm just going to go LCD, and here I'll try to x plus 1 cubed, so that's our LCD. So here they just cancel, and they get the 4x squared plus 11x plus 10. Here I'll have, and if you just kind of picture this sitting next to each of these, that it distributes through. So that'll be a and then x plus 1 squared, because I have 3 up and 1 down. And then b, x plus 1, because I have 3 up and 2 down, so 1 left. And then 3 over 3 of these just clear, and that would be c. So what I can do now is I have 1, 0, and that is x equals negative 1. So I'm going to plug that into this side, and that will be 4 times negative 1 squared, so that'll be a 4, and then that'll make a minus 11 plus 10. So that's just negative 1 there, and there makes this. And then on this side, negative 1 here cancels out the a term, negative 1 here cancels out the b term, so I'm just left with c. And then that's 4 plus 10 would be 14 minus 11, so that means that c equals 3. So once I have that, then what I'm going to do is I'm going to plug, and I'm not going to write this step out because it's just a lot of writing. I'm going to take 3 and I'm going to put it right here. And then I'm going to subtract 3 on both sides. And so what I'm doing is I'm getting just my terms with x's, a's, and b's, actually a's and b's over here, and then trying to get everything else over this side. So then let me come down here with it. That's going to be 4x squared plus 11x plus 7 equals, and I'm going to go ahead and FOIL that out, and that would be x squared plus 2x plus 1 plus bx plus 1. And then I'm going to run the a and the b through. So this is ax squared plus 2ax plus a plus bx plus b, and that still equals this. And now I'm going to kind of group these in a way that makes a little more sense. So I'm going to do descending order, and here I'm switching into method 2 is basically what's happening. So I got ax squared, I have a linear term there and there, so I'm going to think of that as plus 2a plus b. And then just for the sake of space, because I'm going to run out of it, I'm going to do the little factor at the same time. So if you just kind of picture those two sitting next to each other, there's my 2ab, and then factor the x out, and you're right here. And I have a plus a and a plus b left. So I'm going to think of those as kind of plus a plus b. And let me rewrite this side. And so now what we can do is just match up coefficients. So right here I have 4 is a, and then 11 is this 2ab, a plus b, because it's what's in front of x. 7's the thing on the end, so this makes that. So, and we already knew c from back here. So right there we have a equals 4. We have 2a plus b equals 11, and then a plus b equals 7. So if a is 4, if I put 4 right here, 4 plus b equals 7, scoot that over, and I have b equals 3. And then if I want to do a little check, I can put these in the third equation to make sure they work. So 2 times 4 plus 3 does make 11, so that's a good sign. So then this would be A was 4, B is 3, and C was 3.